Optimizing the MySQL server environment, part 1 of 2. In this nugget, we take a look at the physical subsystems of your MySQL servers and provide some handy tips from the MySQL certification team in terms of what hardware is best optimized or best suggested for a typical MySQL server software installation. Second part of this nugget, we'll look at the disk subsystem and the optimal configuration in terms of disk arrangement for, say, database files and log files. Let's get to work. Selecting hardware for MySQL. As previously stated in this nugget series, the bottom line is, with any server software, much less MySQL, the more hardware you're throwing at server software, generally speaking, the better it's going to perform. Certainly for a relational database management system such as MySQL, memory is a particularly important subsystem, and the reason, which I've stressed over and over again, is caching. Adding more memory is going to allow MySQL to create larger buffers. This is going to improve caching and minimize disk activity. Again, remember that memory is infinitely faster. Well, maybe infinitely is a bit of an exaggeration, but memory is certainly exponentially faster than having to go to the hard disk, which we'll look at momentarily, and is therefore going to reduce that swapping of data between disk and memory. Another subsystem we're looking at, of course, is the processor or the CPU subsystem. Perhaps the biggest thing you can do with MySQL is to move from a 32-bit architecture to a 64-bit one. This is doubling the address space. Well, it's actually doing more than doubling if you do the binary math, but certainly from 32 to 64, that number itself is doubling. And in terms of mathematical computations, in terms of memory address space, in terms of physical RAM capability on the motherboard, there's nothing but positives in terms of MySQL capability in your upgrading your processor, upgrading your motherboard, upgrading your server from a 32-bit processor architecture to 64-bit. Of course, MySQL does come in a 64-bit edition, so you're not losing anything there. Windows and Nix obviously both have 64-bit editions as well. What are some hazards or gotchas with 64-bit architecture? Of course, there may be compatibility issues with your LOB or line of business application. This is a limiting factor with some shops. They have to rewrite their code to be 64-bit compliant. I mean, it's one thing to have your OS 64-bit. It's another thing to have MySQL 64-bit, but unless other components, instance your device drivers, your line of business applications, etc., if any of those have to go back to 32-bit compatibility mode, you wind up losing some of the speed advantages of a true 64-bit system. Also remember that 64-bit, because it's tied to memory and memory address spaces, we're able to introduce larger cache sizes as well, and there's the general refrain, larger cache sizes mean more data put into high-speed areas, and ultimately faster and more efficient performance for your MySQL server, and happier users, and happier bosses. And of course, the bosses are the people who sign our paychecks and give us our job security as MySQL developers and MySQL DBAs. The third subsystem for MySQL, or really any server, is the network subsystem. Here we're simply moving. Of course, I'm hoping that you're not in a 10 megabit network. I hope that at the very least you're dealing with 100 megabits per second. But here the idea is to just move as gradually and steadily as possible to a faster backbone. The faster your network connection is, the smaller or lower your resource contention is. Contention, of course, deals with competition for those network resources. And there's different schools of thought here. The general school of thought is to have your users as physically close to your MySQL server as possible. Makes sense. You may have your MySQL server in a server rack and connected to other servers or at the network core using gigabit connectivity, and then have 100 Mbps at the switches going out to the user's desktop. And depending upon how many intermediary links between the switches and the core and the users, it's not necessarily signal degradation you're worried about, but other things that could possibly go wrong in that signal chain. The closer we can get the users to the source server, the more reliable the connection, possibly the faster the connection, and again, depending upon other factors you have on your LAN, the least amount of contention among users for those MySQL resources. Another network-related thing you might want to consider is network redundancy. There's a variety of different things you can do to provide network redundancy on a MySQL server. You could do teamed network interface cards and combine bandwidth such that if one network interface goes down, the other one still remains standing. The two network interfaces can be combined for additional bandwidth, and so on. Again, for the exam, you just need to know the general points here. We're not dealing with the CompTIA A+ or the CompTIA Network Plus or the, for instance, Cisco CCNA certification. We're just dealing with general principles related to these four main server subsystems and points to keep in mind when you're purchasing hardware and making tweaks or perhaps even building out a network that will include one or more MySQL servers. The fourth and final subsystem for a server is the disk subsystem, and we're going to cover that in the next whiteboard. Configuring disks for MySQL. This is a really geeky subject, and it's a pet subject of mine. I enjoy talking shop with other IT pros. However, I'm going to constrain our discussion here as closely as possible to the certification objectives, and the tips I'm giving here are constrained to what you'll find in the MySQL certification study materials. Number one, when you're looking at physical disk characteristics, some technical points up here, you look at what disk controller you'll find on the motherboard, or possibly expandable disk controllers, for instance, an external or internal RAID card, redundant array of independent disks, redundant array of inexpensive disks. There's about 4 or 5 different ways to define RAID, but the bottom line is RAID is a way to provide enhanced speed and or redundancy at the disk subsystem. There's the question of going SCSI or SATA or solid state. So there's physical disk architecture questions. And then I'm going to throw an asterisk on this third point. Are you looking for seek time or transfer rate? When you're looking at statistics, you're oftentimes looking at different numbers and you're wondering which numbers are more important than others. According to the MySQL team, always look for the smallest seek time when purchasing disks for MySQL as opposed to the highest transfer rate. You might be tempted to go for a quote-unquote fast disk that transfers a high amount of data, but seek time is actually most important. In other words, we want a disk that can retrieve data in the smallest amount of time. It's not so much grabbing huge amounts of data off the disk. We want to be able to find the data in the shortest amount of time. You know why? Well, it's the point that I made in the previous whiteboard. As long as we've beefed up the server with lots and lots and lots of RAM, and hopefully we're running a 64-bit architecture, and which is going to allow us to go beyond that 4 gigabyte limit that we've been used to in a 32-bit architecture for years and years and years, we should have more than enough room in our memory buffers to store lots and lots of frequently accessed and frequently used and frequently requested data. Therefore, we should only be hitting up the disk subsystem when we absolutely need to. So this is an important distinction here. Look for seek time as opposed to transfer rate. Now, given the choice between SCSI and solid state is going to win the day in my book every day and twice on Sunday. Chief reason being, I'm going to take a device that has no moving parts, that uses flash memory, over a device that uses moving parts, a mechanical drive like traditional ATA, serial ATA, or SCSI. In the field, I can't tell you how many times I've had drive failures. It's just a way of life with mechanical hard drives. Of course, even as of this recording in late 2009, solid-state drives are still mucho dinero. However, I'm sure you'll agree with me that as time goes on, I suspect we're going to see more and more solid-state drives in servers and fewer mechanical drives. At least I hope so. Alrighty then, so those are the technical points. The other asterisk, the other exam objective here dealing with configuring disk is, alright, given that we have multiple physical spindles, if we're using mechanical drives, spindle of course is a mechanical drive term, where do we put our databases, where do we put our log files, and where do we put our temporary files? This layout that you see in the middle of this whiteboard gives us the recommendation from the MySQL team. In this example, you see 5 physical disks. These are not partitions on a single disk spindle. This is meant to denote 5 separate disk devices. And you'll note that what we're doing here, this is an optimum layout, by the way, is we're putting databases on separate disks. We're separating our log files, our error log, our slow query log, our general log, general query log, and so on a separate disk. And we're putting our temporary file storage on yet another disk. So this is a fully partitioned MySQL data directory is what it is. And you'll notice that I've put an annotation down at the bottom that in order to do this, in order to spread out your databases outside of the traditional single directory, you'll remember the system variable datadir. By default, we have just a single directory path under which all of our databases live. In order to spread your databases out or put them in an alternate location, we have to create what are called symbolic links that point to those alternate locations. And I'm actually going to show you how to do that in the upcoming demo. If you're not familiar so much with Linux, Unix, a symbolic link is essentially the same thing as an alias in Mac OS X or a shortcut in Microsoft Windows. It's basically a pointer, a placeholder pointer that you put in location A that maps to a physical file system resource that you've moved or just simply exists in location B. So for instance, in the upcoming demo, I'm going to take the world database out of the default datadir on my WinNugget machine and move it to a different location. And I'm going to stick a symbolic link in the original datadir that essentially informs MySQL, hey, if you're looking for world, look over here in this alternate location. It's a simple shortcut or an alias, nothing more than that. Speaking of demo, why don't we hop into the lab portion of this nugget with no further ado. We're simply going to work with symbolic links. I'm going to show you how to move a database to a new location. We're going to do that in Windows. And then let me scratch out log file. I'm going to show you how to move the entire datadir, not just a single database, but the entire datadir to an alternate location if you decide after installation, hey, I don't like the default location where datadir is. Maybe I'm running out of space on that file spec. I'd like to move it to another spot. And we're actually going to do that on LinNugget. Let's get rocking. We're going to begin this demonstration on WinNugget 1. And to review what we're going to do is we're going to take the world sample database out of the default datadir, which on this machine, since I did a typical installation of the Windows installer-based MySQL distribution, exists on C, program data, MySQL, MySQL Server 5.1 data. There's world right there. I'm going to move that guy to an entirely new file spec. First step, of course, I'll need to create that folder. So I'm going to browse to the root of drive C, and I'm going to create a folder, and I'm going to call it new datadir. Not very creative, I know, but we'll also want to right-click that folder, go to Properties, navigate to the Security tab, and we'll want to verify that our permissions are set properly. If we created a service account specifically for MySQL, we'll want to make sure to load that into the access control list and give it full control permissions. If the service account is an administrator already, we should be okay. On Windows Server 2008, the local administrators group already has full control permissions by default. All right, before I actually move the world folder, I'm going to stop the MySQL service. I'm going to elevate myself here, right-click the command prompt, run as administrator, net stop MySQL. Of course, I wouldn't want to do this in a production environment unless we were off hours or during scheduled downtime. Now that the service is stopped, I can arrange my windows in such a way as to make movement possible. I'm going to right-drag world into C, new datadir. I'm going to move that guy in there. Cool. Let me re-invoke my datadir because we're certainly going to need this back now because we need to inform MySQL of the new location of our world database. To do this, we're going to create a symbolic link. Let's right-click, go to New, create a text document, And this document will be called world.sym. Let me get rid of that txt extension. Confirm that I want to change the extension of the file. Shows up as a blank paper icon because by default, Windows doesn't know how to associate the file yet. But that's not a problem because we'll double click the file and we're going to crack it open with WordPad. With Notepad. Notepad is fine. All this file needs to contain is the full path, absolute path, to where the world database actually resides. And we know that it resides in C, new data dir, world. That's all. So we'll save the file, close it up, and that's all there is to it. World.sim. So we can close the data dir, reopen our command prompt, start the MySQL server again. Let's log in, show databases, use world, select against world, and finally, let's show our data dir. Our data dir, of course, hasn't gone anywhere. It still exists in our regular location. But world has most certainly been relocated to its new location in C, new data dir. And just to be absolutely positive that it's working, let's create a new table in the world database and verify that those files are created in the new location. So what I'll do is create a table called foo that has one column, and I'll make sure that I'm using the MyISIM engine. So there's the table. It shows up in the MySQL client. We'll come back into the new data dir, refresh our view, and there we go. We've got the foo format file, the MYD file, and the MYI file. Rock and roll. As you see, I've now moseyed on over to LinNugget1, and I've logged into MySQL Server. I've also brought up a couple variables. My base dir or base installation directory on an Ubuntu-based install here is USR. My data dir is varlib MySQL. And in this example, I'm finishing out the nugget by moving my entire data dir to a new location. And my new path is going to be user new data dir. So just to let you know in advance. So we're going to grab the entire data dir and move it to a new directory path. Now in the real world, you would take your data dir and move it to an entirely different disk. But on this server, because I have only one hard disk, I'm going to demonstrate the exact same procedure, simply substituting a different directory path instead of a different disk. Same procedure though. Alright, so let's get out of MySQL. I'm actually going to SU and become root here for convenience. And now that I'm root, the first thing I want to do again is stop the server. And on Ubuntu here, the procedure is etc init.d MySQL stop. If I can type, of course. It's not init ID. Next step, I'm going to use the mv command to move my data dir at var lib MySQL to the new location, which, as you know, is USR new data dir. Next, I'm going to create my symbolic link. And in Linux Unix, we do this with the link command or the ln. I'm going to create a soft symbolic link with the -n switch. And this is done. I specify my real location first, USR new data dir, space, then my original location. Let me check that syntax again. ln-s, user new data dir, var lib MySQL. Looks good. Final step, start MySQL, and let's log in. Show databases, use world. Interestingly, you'll note that the data dir still shows up with the original value. You quit out and launch an administrative Nautilus shell. And if I navigate to var lib MySQL, the files all appear to be there. However, if I navigate to USR new data directory, the files are there. The symbolic link is working as expected. Optimizing the MySQL Server Environment Part 1 of 2 review. In this nugget, I gave you some best practice suggestions for selecting hardware for a MySQL Server installation. We looked at those 4 main subsystems of really any server. You'll recall we have the disk, the network, the processor, and the memory subsystem. And although you can apply these suggestions to really any client-server application, you'll want to remember the general tips I gave you in this nugget so you can master any related questions you see on your MySQL DBA2 exam. In the second part of this nugget, we drilled into the disk subsystem in greater detail, and I provided you the formal suggestions for fully partitioning an installation of MySQL data directory. In other words, how to, for instance, move a particular database out of the data directory and establish a symlink or symbolic link to it. And then in the demo, I showed you how to move the entire data dir to an alternate location. I hope that this has been informative for you, and I'd like to thank you for viewing.